Welcome to this 3D walkthrough of an AI-powered deep neural network pipeline, applied across multiple ERP modules. This model, designed by Pradeep K. Suri, illustrates how a single neuron formula can unify diverse business systems visually, mathematically, and logically. Mentor-focused explanation of video ed animated DNN.mp4, which animates a 3D deep neural network, DNN, pipeline across ERP modules, tailored for training sessions and professional mentoring. AI 3D model by Pradeep K. Suri. Brain Mentors explanation, animated 3D DNN across ERP modules. This training video begins by visualizing ERP modules in a 3D circular formation, where each node, example sales, inventory, HR, production, represents a distinct data-producing domain within an enterprise. These modules act as input layers feeding into the AI engine. The animation introduces these inputs one by one, allowing learners to clearly see how domain-specific knowledge such as customer orders, employee metrics, inventory counts, or financial trends flows into the AI model. As each ERP module connects to the central neuron core, mentors can emphasize the concept of data unification and abstraction, a core idea in DNN logic. This neuron core, labeled same neuron formula, applies the mathematical transformation. Y equals sigma, W1x1 plus W2x2 plus WNxN, Y equals backslash sigma, Wx plus W2x2 plus Wx, Y equals sigma, W1x1 plus W2x2 plus WNxN. This shared formula is critical in mentoring AI practitioners to appreciate that the same architecture can serve diverse ERP domains through intelligent feature engineering. The animations layering ensures that each module's link to the neuron is clean, visual, and easy to follow. Finally, the animation depicts 4 key output pathways: predicted output, Python library, formula expansion, and branch of math. This is a valuable teaching moment. Mentors can now explain not only what the model produces, but how it interprets, which libraries are used, example TensorFlow, scikit-learn, and which mathematical foundations, linear algebra, statistics, empower the AI logic. The visual symmetry and animation pacing make this ideal for engaging learners, project teams, and functional managers alike. Keynote with thanks for exploring this animated walkthrough of a 3D deep neural network applied across ERP modules, designed and mentored by author, Pradeep K. Suri. This video isn't just a visual journey, it is a blueprint for how we can reuse the same neuron formula across complex business systems. Whether you're training interns, onboarding AI engineers, or presenting to management, this animation helps bridge the gap between domain data and deep learning logic. Let it inspire teams to build modular, scalable AI engines across industries. 3D Deep Neural Network, DNN, pipeline across ERP modules. Here's how the model, or cube, can produce distinct reports and graphs for various levels of management. Bar chart reports and graphs by role level. Classical building 1. Top management, strategic level. Objective, decision making, growth forecasting, risk evaluation, and high-level summaries. Chart increasing reports. Executive KPI dashboard, multi-domain, real-time. Forecast accuracy report, sales, demand, budgeting. Profitability heat map by ERP module. AI-powered risk index, legal, financial, compliance risks. Innovation impact report, from AI adoption. Bar chart graphs. 3D heat maps, cross-domain performance. Bubble charts, risk versus ROI. Trend lines with confidence intervals. Sankey flow for revenue streams. AI-driven forecast versus actual graph. Puzzle piece 2. Middle management, tactical level. Objective, monitor performance, ensure departmental alignment, analyze trends. Chart increasing reports. ERP-wise contribution report, sales, HR, inventory, etc. Process delay and bottleneck analysis. Neural model recommendation summary. Vendor and customer insights from AI. Department-wise target achievement. Bar chart graphs. Stacked bar graphs, monthly department outputs. Waterfall charts, inventory levels, cost breakdown. Correlation matrix, feature impact on outcomes. Funnel charts, sales conversion, hiring pipeline. Spider/radar charts, department competency. Gear 3. Operational level, execution level. Objective, track daily KPIs, follow alerts, optimize tasks, apply model outputs. Chart increasing reports. Daily supply chain status. Employee performance tracker. AI-based quality inspection report. Real-time demand supply report. Maintenance alerts and anomalies. Bar chart graphs. Gantt charts, task completion versus plan. Line and bar graphs, productivity, order fulfillment. Threshold alerts with color indicators. Live status dashboards, manufacturing, logistics. Time series graphs, sensor logs, inventory days. Brain the Cube model's intelligence layer. All these reports and visuals are enabled by the neuron formula, which standardizes and transforms input from different ERP sources. Learns patterns using weights and activations. Predicts trends, anomalies, and optimization paths. Provides explainable outputs linked to business logic. Explanation of the video book reservation.mp4, which visualizes a book reservation trend by semester through a combined bar and line chart, modeled as part of the 3D DNN Cube system by Pradeep K. Suri. Purpose and structure. The video begins with a clear presentation of semester-wise trends in book reservations within a library ERP system. Each semester from semester 1 to semester 6 is represented along the horizontal axis. The bar chart, rendered in vibrant blue, showcases the volume of books reserved during each academic period. This sets a visual rhythm for how library resource demand evolves across time. Insights through visual comparison. Alongside the reservation bars, a vibrant pink line chart overlays the data to represent reservation cancellations. This dual chart structure enables viewers to compare positive user engagement, reservations, versus disruptions or drop-offs, cancellations. Patterns emerge. Semesters with high reservation peaks also show noticeable cancellation spikes, suggesting either overbooking or unmet demand. This dual graph style enhances interpretability for middle management and library planners. 3. Link to the 3D DNN Cube model. This visualization is derived from the 3D DNN Cube conceptual model, where each ERP module including library ERP feeds into a shared neuron logic formula. That formula, y equals sigma, w1x1 plus w2x2 plus wnxn, y equals \sigma, wx plus w2x2 plus wx, y equals sigma, w1x1 plus w2x2 plus wnxn, processes semester level data and generates predictive outputs such as demand forecasts, cancellation likelihood, and resource reallocation needs. The trend video thus acts as a visualized output layer from the deep learning engine modeled by Pradeep K. Suri. 4. Mentor takeaway and use case. For mentors, this video provides a rich teaching aid to explain how AI can assist educational institutions in optimizing library services. From a training perspective, it demonstrates how clean input data, semester IDs, transaction logs, transforms into actionable insights using modern AI visualization techniques. Whether for student service teams or administrative leaders, this video fosters awareness of data-driven planning, leading to smarter resource allocation, user satisfaction, and better academic support systems. Thanks for watching the video.